Hello and welcome. This video we will continue our discussion on types of relations. This video will discuss symmetric relations. Symmetric relations. Let's see the definition for symmetric relations. A relation R is said to be symmetric. Is said to be symmetric if both A comma B and B comma A belongs to R. So what does it mean? We'll take an example to understand this. I have a set A equals 1, 2 and 3, and if I define a relation of A as 1 comma 2 and 2 comma 1, then this relation is symmetric because you consider this as A and this as B. So A comma B is in relation R, as well as B comma A is also in relation R. So if both A comma B and B comma A are present in R, then such relation R is symmetric. Take one more example. Let's say I have R is equal to 1 comma 3, only this, and this is not symmetric. This is not symmetric because 1 comma 3 is in R, but 3 comma 1 is not in R. So such relations are not symmetric. So here one thing we have to note here is if take it as a note, if A comma B is present in R, only then the presence of B comma A matters to determine whether R is symmetric or not. So what does it mean? Let us take an example to understand this. If I have R is equal to 1 comma 2 and 2 comma 1, and let's say 1 comma 3, this is my one example. If I write R is equal to 1 comma 2 and 2 comma 1, so here this is not symmetric. Because 1 comma 3 is there in R, but 3 comma 1 is not in R. So here in the second example, this is symmetric because both 1 comma 2 belongs to R and 2 comma 1 belongs to R. So here we don't have 1 comma 3. So it means if very important is, if A comma B is present in R, only then you check for B comma A in R. So if A comma B is not in R, then no need to check the presence of B comma A. So what does it mean? It means if A comma B is in R and B comma A is also in R, then R is symmetric. Then R is symmetric. If A comma B is in R and B comma A is not in R, then R is not symmetric. So these two are pretty straightforward. Third case is, let's take this as first, second, third case is really important. If A comma B is not present in R, then R is symmetric. Then R is symmetric. So if A comma B itself is not in R, then we need not to check for B comma A. Such cases R is symmetric. So this leads us to one of the very important point. It is, if I have an empty relation, if I have an empty relation, R is equal to like this. So here there is no pair. So we don't have any elements in R. So since we don't have any elements in R, it falls to category 3. So here we can say R is symmetric. R is symmetric because if A comma B itself is not in R, we need not to check for B comma A. In such cases, R is symmetric. So all empty relations are symmetric. All empty relations are symmetric. So what about universal relations? So let us take an example. We have, let's take A equals 1, 2 and 3. So let's take the universal relation R is equal to 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3. Finally we have 3 comma 1, 3 comma 2, 3 comma 3. So let us come to the first element. So 1 comma 1. So we know that in set we write every element only once. So even though if it is repeated many times, we write it as 1. We write it only once. So if any element in the set is written once, we can write it as many times we want according to our convenience. So 1 comma 1 I can write 2 times. So I can write R as 1 comma and 1 comma 1 and so on. So here this is my A, this is my B, so this is B and this is A. So 1 comma 1 is present in A and 1 comma 1 is also present in A. So for this it is symmetric. So we need to check for 1 comma 2, 1 comma 2. So for 1 comma 2 we already have 1 comma 2 we already have 2 comma 1. So this is done. For 1 comma 3 we have 3 comma 1. For 2 comma 2 any of 2 comma 2 can be paired with 2 comma 2. So this is fixed. For 2 comma 3 we have 3 comma 2. Similarly for 3 comma 3 we can write 3 comma 3 again to satisfy this condition. So we can conclude universal relation is always symmetric. It's always symmetric. So empty relations is also symmetric. Universal relation is also symmetric. Let us take few more examples to check whether the relation is symmetric or not. We'll take R is equal to, let's define A. A is 1, 2, 3. R is 1 comma 1. Is it symmetric? Yes, it is symmetric because if we have 1 comma 1, I can write 1 comma 1 as many times I want to satisfy my requirement, because in every set we write element only once. Even if it is repeated many times, we write it once. So if any element is once, we can write as many times we want. So this is A, this is B, this is B, and this is A. So in this case, R is symmetric. R is symmetric. Let's take one more example. R is equal to 1 1 1 1 2 2 3 3 and 1 comma 2. So here 1 1 2 2 3 3 are self-symmetric. So let us come to 1 comma 2. So 1 comma 2 is in R, but to support this we don't have 2 comma 1 in R. So this case it is not symmetric. This case it is not symmetric. Take one more example. R is equal to 1 comma 3 and 3 comma 1. This is clearly symmetric, because since we have 1 comma 3, and to supporting that we have 3 comma 1. And finally we take an empty relation. We know that an empty relation is always symmetric, because there is no element a comma b is not in R, and there is no need to check for b comma a, so it is symmetric. In the next video we'll discuss one more type of relation, that is transitive. Thank you.